Okay, so let's take a look. This would be a calorimetry problem. I try to squeeze the values in here. They didn't type over, so hopefully it's not too confusing. So in a coffee cup calorimeter, so as soon as I see that, I know I'm going to have to equals Q equals MCAT. Okay, 1.6 grams of ammonium nitrate is mixed with 75 grams of water, initial temperature of 25 degrees Celsius. After dissolution of the salt, the final temperature is 23.34 degrees Celsius. Assuming the solution has a heat capacity of 4.18 joules per gram degree Celsius and no heat loss, calculate the enthalpy change for the dissolution of ammonium nitrate in units of kilojoules per mole. Right. So first step with calorimetry, we always want to find the heat. Okay. So we have the mass. So the mass is going to be 76.6 grams. So that's the mass of the ammonium nitrate plus the mass of the water times 4.18 joules per gram degree Celsius times the change in temperature. So in this case, it's 23.34 minus 25.00 degrees Celsius. So what I would do if I were you right now is go ahead and pause and try to solve this question. And then after you do it, then you can go ahead and play through the video and see if your answer is correct. All right, so let's go ahead and finish this out. So let's calculate the Q. So I'm going to multiply all that together. And what I got when I put that in my calculator was a negative 531.5 degrees Celsius. Okay. Remember, negative heat is telling me what? This system is gaining heat, right? So this is an endothermic process. We see that by the decrease in temperature, right? So it's absorbed energy, okay, to get it up to the reactants up there, right? So the products, reactants, and the products. So the temperature actually decreased. I don't know why I wrote that as Celsius. All right, so let's go on here. So now we found the Q, but now I want to enthalpy change, right, or the delta H. And how do we go from delta H in Q? We know that delta H is equal to negative Q divided by moles. Okay, so let's go ahead and solve for that. So we have 1.60 grams of ammonium nitrate, and I have my Q. So I can convert this to moles, and I have my Q already, so I'm going to say delta H is equal to a positive 531.5 joules divided by, let's find the molar mass. So find the molar mass for this compound. And I found the molar mass to be 80 grams per mole. So 1.6 divided by 80 grams per mole comes out to 0.02 moles. So I'm just going to plug that back into this equation over here. So 0.02 moles. So 531.5 divided by 0.02 moles. And I got a delta H of 26,575 joules per mole, or 26.6 kilojoules per mole. Okay, so remember when we're solving calorimetry problems, the two important things we need to know. First off, we're going to use Q equals MCAT to find the heat associated with that reaction. Then we're going to convert it over to enthalpy changes by negative Q over moles. And the moles that we're dealing with are always moles of the chemical, okay, not moles of the water. All right, so I just want to know, in this case, how many moles of ammonium nitrate do I have? I don't care about how many moles of water I have, just how many moles of ammonium nitrate.